Namaste, I am Nivedita, Assistant Professor, Department of ECE, MIT, Mysore. This semester I will be handling a subject called Digital Signal Processing Laboratory with the subject code 18ECL57 for 5th semester students. Now let us see what are the syllabus included in this particular course. So I have listed out the experiments in the syllabus. The first experiment we have is verification of sampling theorem. Then we have a computation of DFT and IDFT. Then we need to calculate what is the value of difference equation. Next we have calculation of linear and circular convolution. Then we come to a correlation where it includes two different types. One is the autocorrelation and another one is a cross correlation. Along with this, we need to study the design and implementation of FIR and IIR filters. So all these experiments listed in the syllabus will be executed through the software called MATLAB, that is Matrix Laboratory. Why it is called as a matrix laboratory? Because whatever the data you enter into this particular software, it considered it as a vector, array or a matrix. Hence it is called as a matrix laboratory. This particular software is a high level language which is a case sensitive language. So this is about a matrix laboratory. So now let us discuss the first program which is there in the syllabus, that is verification of sampling theorem. So now I am going to tell you the logic behind the MATLAB program for sampling theorem. So before that, let us see what is in sampling theorem. What is the sampling process actually? So sampling is a very basic step which is needed for the conversion of analog signal into the digital signal. Okay. So while converting a analog signal to a digital signal, we need to follow a first step called sampling. Okay. At this sampling end, we are going to get an output as discrete. Okay. So after the sampling process, we are going to get an discretized value of the analog signal. This sampling has to be done according to the rate that is called as Nyquist rate. So this Nyquist rate, it is nothing but the sampling frequency which is always indicated by Fs. This should be greater than or equal to the twice of the, that is 2 times of the maximum frequency of the message signal. So this condition is very important for a sampling process where Fs is greater than or equal to twice of maximum frequency. Why this condition is needed? Because so while doing the reconstruction of analog signal after the digitization process, if you want to reconstruct it exactly as a given input, so you need to follow this rate, that is Fs greater than or equal to twice of a maximum message signal frequency. Okay. So keeping this condition in the mind, let us write a program for the sampling theorem. So now, since you don't know what are the commands we are going to use in a MATLAB, I'll tell you what are the first initial commands you need to write while writing a MATLAB program. So first, very beginning, you need to start it with CLC. So that means it clears the screen. Okay. Then clear all. So we need this clear all to clear the previous data there in the software. Okay. So CLC then followed by a clear all. every line of a MATLAB program should end with this semicolon. So otherwise you are going to get an error. Okay. Now, so after these two instructions, first let us plot an signal. So either you can plot a sine wave, cos wave or a composite wave, which is a combination of two cos waves or two sine waves. Okay. So now I am going to plot an composite wave, which is a combination of two cos wave. So if you add any two cosine wave or a sine wave, it always results in a random wave. So a random wave will be like this. Since it is of cos, so it always starts from its maximum value. Okay. So now after writing these two instructions, let us write the parameters required for the plotting of a signal, that is a virginal signal. So still we have not gone to a sampling process, just we are plotting a virginal wave. Okay. So now for any wave we need a frequency, right? So every wave will have a frequency. Now I'll consider the first wave frequency as 1000 or it is a 1 kilohertz. And similar to that, I'll go for a second wave, which is nothing but F2, which is having a frequency of 1900, 1.9 kilohertz. So now, for a sampling process, as I told you, we need to go for a maximum frequency of the considered wave. So since I am taking two different waves with the different frequencies, I will take the maximum frequency of these two. So I will write a next sentence in the program as F max. So what is F max? It is the maximum value of F1 and F2. So I will write a command as max of F1 comma F2. So now it considers a maximum frequency of these two. Then for every wave, you know, it will be having certain time period. For a time period, you need to go for a capital T. So that indicates a time period of a wave. So what is T? We all know it is a reciprocal of frequency. So now you can write it as 1 by. Since it is a reciprocal value, you need to consider it as minimum of F1 comma F2. So this gives the time period. Then let us go for a time axis value of the virginal signal. So every wave has to start from its 0th position. Hence, I'll write 0 first, then 2, 0, 2. So where it should end? So I'll take a ending value as twice the time period value, 2 into. So into in a MATLAB, it is indicated by star operator. 2 into capital T. So what is our intermediate value here? Intermediate value will be the scaling factor. So whereas the simultaneous wave should start. So I'll take any value. So as 0.01 times of T. Okay. So it has to start at 0 position and it has to end at 2T value. And the intermediate value will be 0.01 into T. So at this stage, so we can easily plot a virginal signal which will be like this. So it is nothing but a random wave. Why we are getting random wave? Because we are adding two cos waves. I'll write a program for that. So these are the just parameters which are needed for a plotting of waveform. Now let us see the second part of a program, how to plot a virginal signal. So now, in order to plot a virginal signal, as I told you, I am considering two cosine waves. That is a composition of two cosine waves, cos plus cos. These two signals will result in a random signal. For a cosine wave, we have a standard equation cos 2 pi ft. Since I am considering two different frequencies, f1 and f2, I am writing this cos wave equation for two frequencies, cos 2 pi f1t plus cos 2 pi f2t. Then, here in this entire program, I am going to plot four different waveforms. First waveform is a virginal waveform. So, since I am firstly representing a virginal waveform, I am going to divide a figure window. So, here we are going to see the output in a window called figure window. Figure window will be divided using a instruction called subplot. I will tell you what is the subplot equation. This standard equation of subplot, it includes three parameters, m, n and q. What is m? It is a number of rows. What is n? It is a number of columns. Q represents the quadrants. Since I am representing four waves, I need four different quadrants. When you are going to get a four quadrants? When you have two rows, two columns and four quadrants. So, out of four quadrants, firstly I am representing virginal wave in the first quadrant. It will be like this. The figure window is having now two rows, 1, 2, two columns, 1, 2. So, how many quadrants? 1, 2, 3, 4. In that, in a first quadrant, I am displaying virginal signal. Hence, I have written the instruction as subplot of 2, 2, 1. 2 rows, 2 column, and in a first quadrant I am displaying virginal signal. Then we have another instruction in the MATLAB called plot. Why we use this plot? Plot is mainly used to get a continuous wave. Whereas to get a discrete wave, you need to use an instruction called stem. Since I am firstly plotting a continuous virginal signal, I have used a instruction called plot. For every plot instruction, first you need to represent a x-axis value, then you need to go for a y-axis. So, as we all very much familiar about the waveform, the x-axis should be always a time axis. Hence, here I have taken it as t. What is x? It is nothing but a amplitude of virginal wave, which is indicated here, t, x. For every wave, let us give a x-axis, y-axis, then a title. So, what is the first wave we are displaying now? It is a virginal signal. Give the title within a single inverted comma as continuous signal. It will be continuous in nature. Then give the x-axis through an instruction called x label. It is time t. And y label as x of t. It is a continuous time signal which is indicated by x of t. So, this part will give an output in the figure window as like this. This is a virginal wave. So, this wave is random in nature because it is a composite signal. Okay, and this will be the continuous signal. Now, I will explain the next part of a program where we are going to see the exact sampling. What is an exact sampling? So, this exact sampling is according to the Nyquist rate. The frequency will be considered is equal to the twice of the maximum frequency. So, now let us take the first sampling frequency as fs1, which is equal to twice the maximum frequency. So this is a condition for exact sampling. Then we need to take the x-axis value. Here, after sampling, what we are going to get? We are going to get a discrete signal. For a discrete signal, we have a x-axis value as n. For a continuous time signal, it will be t, small t. For a discrete signal, it will be taken as small n. So now, since it is with respect to first sampling process, I have taken it as n1, which is equal to every signal, it has to start from its origin value 0, hence here also I have considered it as 0. And where it has to end? At the 2 times of capital T value. So you can give any intermediate value, so it will be always the reciprocal of given frequency, that is fs1. So it is 1 by fs1. Now let us go for a signal plotting. So x1, it is having 2 cosine waves, 2 pi f1 into, here you have to use n1, and similarly plus cos 2 pi f2 into, it has to be again n1. So these two will give you an sampled wave of a virginal signal, which is according to the exact sampling. Now, where you need to display the signal? So in the figure window with second quadrant. So in the first quadrant, we have already displayed the virginal signal. In the second quadrant, let us display an exact sampling waveform. Then what is the instruction you need to use now? It is subplot of 2, 2. With respect to second quadrant, it has to be 2 again. And this signal is a discrete signal. In a MATLAB, to plot a discrete signal, you have to use an instruction called stem. So stem of, so first signal value will be the x-axis value n1, and then the y-axis will be x amplitude value, that is x1 here. Then let us hold this figure as it is. For that, let us use an instruction called hold on. On this discrete signal, let us plot a continuous signal also, just to see the difference of sampling process. For a continuous wave, we have a function called plot in the MATLAB, that is plot of, again x-axis value n1 and y-axis value x1. With a different color also, you can indicate this waveform with respect to single inverted quotes. So here I have indicated is R. What is R? This waveform will be represented with red color, that's it. Then for this waveform also, you need to give a title. So what is title? It is an exact sampling. X label, again it is time n value. Y label, it is a x of n value. Okay, so this is a exact sampling. Coming to the output of this exact sampling, how we are going to see the waveform with respect to exact sampling. For an exact sampling, you are going to get the samples at the maximum values. See here, in the yellow color, I have indicated here all the maximum samples. So that is a discretized value. So after the discretized value, if you reconstruct it with respect to continuous wave, you are going to see the waveform like this. So from the exact sampling, you are not going to lose any of the data from the virginal signal. Hence, for a communication process, exact sampling will be preferred. Now let us see the next condition of the sampling called oversampling. When does this oversampling will come into the picture? When the sampling frequency is considered more than the doubled value of a maximum frequency. Now I am considering a more value with respect to maximum frequency, that is a multiplying 10 into the maximum frequency. So I am considering it as a second sampling frequency fs2. Okay. So fs2 is equal to 10 times of maximum frequency. Now So you need to define a x-axis, that is a discretized value for this particular waveform. Hence write it as n2 equals, again the waveform has to start from 0, it has to end at 2t. And the intermediate value will be the reciprocal of sampling frequency 1 by fs2. Then go for the construction of wave. So it is x2 is equal to cos 2 pi f1 into the considered discrete value n2 plus cos 2 pi into f2 into n2. Then you need to plot this waveform in the third quadrant, because we have already displayed two quadrant waveforms. Now this signal will be displayed in the third quadrant. Go for a subplot equation. It has to be displayed in third quadrant. So now in the third quadrant we are going to get an oversampled waveform. Then after this, let us take the discrete value of these oversampled wave. Stem of again x-axis n2 comma y-axis x2. Then let us hold it for some time. Now over these discrete value, let us plot a continuous wave. Go for plot n2 comma x2, x-axis value, y-axis value indicated with a different color, either in red, blue, yellow, etc. Here I have used R, that is red color. Then give a title for this, oversampling, and mention the X label and Y label. Now let us see how will be the waveform for this oversampling. Oversampling will need a larger bandwidth, and you cannot reconstruct the exact virginal wave here. So if you see the oversampled wave, so you are going to get the more number of samples, not at the maximum peak. So by this you need a larger bandwidth, but you can use it for the communication process. There won't be a loss of data. Now let us see the last condition of sampling, that is a undersampling condition. Let us see how to write a program for this undersampling condition. Now let us consider a frequency of this undersampling process which is less than the maximum frequency. So in order to get a less maximum frequency, I am just multiplying a scaling factor of 1.2 to the maximum value. It obviously reduces the maximum frequency, which will be assigned to fs3. This fs3 can be used to take a n value. So now I will take it as n3. Here also the value has to start from 0 and it has to end at 2t value. And the intermediate scaling value is the reciprocal of the fs3, that is 1 by fs3. Let us construct a waveform here also by taking 2 cosine wave, which is a composite in nature. x3 is equal to cos of 2 pi f1 into the assigned discrete value n3 and plus cos 2 pi f2 into n3. Now you need to display it on a figure window by giving a subplot equation. Subplot, it is left with the last quadrant now, and that is a fourth quadrant. So let us display the undersampled wave in the fourth quadrant. Subplot 2, 2, 4. Since first let us plot an discrete wave stem of n3, x3. Let us hold it for some time. Over this discrete wave, let us plot a continuous wave just to see the difference. Now plot n3, x3, different color indication red. And give the title for this. Title will be a undersampling, x label will be n and y label will be x of n. Now let us see the output with respect to undersampling condition. The undersampled wave will be like this. It will be consisting less samples, and here you can expect to have a overlapping of the signal where you can lose the virginal data. From the undersampling, there will be a loss of virginal data, hence it is not preferred for a communication process. Always for a communication, we are going to use either an exact sampling or a oversampling just to avoid the loss of data. Dear students, now I'll explain how to execute a first program of DSP lab, that is sampling theorem verification using MATLAB. So now first I'll show you how will be the MATLAB icon. So this is a MATLAB icon. So double click on it to open the software. As soon as you double click on the MATLAB function, you'll get a window like this. You can see here you have a different windows. So this is showing a current folder. Then we have a command window and this will be the workspace. So now to type a program, first go to new. There select script. So this will be a MATLAB file, that is M file. So now you got one more window here, which is a editor window where you can type your program. So now I'll just paste the program of sampling theorem. So see here, so this is a file. So which is a completely program for verification of sampling theorem, which is consisting of all the three conditions: exact sampling, oversampling and undersampling. So now after typing a program, you need to save this program. So now click on this icon where you can see a save. Save. So you can create your own folder in any drive and you can save this file. So I'm just saving this file in a desktop and you can give any title. So I'm just giving a title as sampling 1 and every program has to save with a .m function extension. Okay, so it is a sampling 1.m. .m is mandatory for MATLAB file. Save it. Now you need to run this program. So now I'll run this program. Just click on this icon, run. I'm giving change folder. So now I got a output. So you can see here, this is an figure window. So in a figure window, we are getting output. So as we have used subplot function, the figure window has been divided into number of rows and columns, which is having 4 quadrants here because we have splitted this window into 2 rows and 2 columns. You can see here we are having 4 quadrants. First, second, third one and the fourth one. In the first quadrant, we are getting a virginal cosine wave. You can see here the title also is there in the figure window. So it is a random cosine wave. Then for this original wave, we have done the exact sampling process where you can observe only at the maximum peaks we are getting a samples. So from this, you can easily get the waveform, that is a virginal waveform. So reconstruction will be easily done by using exact sampling process. Then we have a oversampled wave. Here you will get a many samples and you can reconstruct that using a continuous waveform. Sampled value will be the discrete one, whereas if you join those sample values, you are going to get a continuous waveform. Red color indication is continuous wave. Then you can see the undersampled wave here. So this wave is not exactly same as the original one, and here there will be a loss of data. Hence, we are going to avoid this undersampling process. So you can see the differences between all the three types of sampling using this program execution. Thank you.